So what if an AI could actually think before it speaks? I mean, really think. Well, a fascinating new paper is doing just that, teaching language models the skill that feels incredibly human. It's called Quiet-STaR, and it's all about giving AI an inner monologue. And let me tell you, the results are already turning a lot of heads.
Okay, take a look at this number. That's a 5% performance jump on GSM-8K. Now, if you're not familiar, that's a notoriously difficult benchmark for solving grade school math problems. 5% might not sound like a world-changing number, but in the hyper-competitive space of AI reasoning, an improvement like this on such a tough test, yeah, that's a huge deal.
And it's not just math. On a test of everyday common sense, the model got a nearly 11% boost. But here's the part that's really wild. These are what we call zero-shot improvements. This means the AI wasn't prepped or specifically trained for these tests. It just figured it out on its own.
So what is the secret here? How did it do that? Well, that is the core breakthrough. You see, Quiet-STaR isn't about teaching a model to memorize answers for a test. It's about teaching it the fundamental skill of reasoning itself, just by letting it analyze all the text that's already out there on the internet.
The core idea is actually pretty simple, but it's also incredibly powerful. The model learns how to generate its own internal thoughts, its own rationales, to better understand whatever it's reading. It's literally developing an inner monologue to think through what it's about to say. And, as you can guess, that leads to much, much smarter predictions.
To really fully appreciate why this is such a big deal, we got to take a step back and understand the fundamental challenge that Quiet-STaR was built to solve. It's something we can call the reasoning gap.
Modern language models, they are masters of prediction. I mean, they're fantastic at guessing the next word. You type run, they know ing is a pretty safe bet. But that's just sophisticated pattern matching. It's not true reasoning. They often completely miss the why, the deeper logic, and the cause and effect that connects all the ideas.
This quote from the research paper just sums it up perfectly. For us, and for an AI, real understanding isn't just about the words you see on the page. It's about all the stuff that's not said, the context that's hidden right there between the lines. That's where the deep reasoning really happens.
All right, so how does Quiet-STaR actually build this inner monologue? Let's dive in and break down how this whole system works.
So, officially, Quiet-STaR is a really unique training method. It teaches the model to generate these quiet, internal thoughts for one very specific purpose, to get better at its main job, which is simply predicting the next word or piece of text.
The whole process really boils down to 3 simple steps. First, the model thinks. For every little piece of a word or token, it comes up with a bunch of possible thoughts or rationales. Second, it talks. It takes its standard prediction and blends it with a new one that's been informed by those thoughts. And finally, and this is the most important part, it learns. It looks back and rewards the thought processes that led to better answers and just gets rid of the ones that didn't.
At its heart, this is just a big reinforcement loop. The model is constantly generating and then judging its own thoughts. The helpful ones, the ones that make its predictions better, get rewarded and strengthened. The unhelpful ones, they just get discarded. And over time, the AI just gets better and better at figuring out which kind of internal reasoning actually works.
So how does the model know when it's supposed to be thinking and when it's supposed to be talking? Well, it uses these special little digital flags. You can think of them like markers that tell the model, okay, start your inner monologue now. And then, all right, time to share your final answer. This lets it switch back and forth between internal reasoning and external output seamlessly.
But hold on, generating thoughts for every single word? That sounds incredibly slow and super expensive. And honestly, it would be. This is where the second key innovation comes in. The researchers came up with a really clever system that lets the model generate all of its potential thoughts at the same time in parallel. This is what makes the whole process actually computationally possible.
So that's the theory. But does teaching an AI to have an inner monologue actually work out in the real world? Let's circle back to those impressive numbers from the beginning and really look at the results.
And the results are, well, they're fantastic. The data shows this crystal clear trend. The more the model thinks, meaning the longer its internal monologues are, the better its accuracy gets on these complex reasoning tasks. It's a direct confirmation that deeper thought really does lead to better performance.
This is obviously a powerful result, but it does raise a pretty key question. Is this new technique supposed to replace the existing methods we have for AI reasoning, or can it actually complement them?
The answer is clear. It's a team player.
When you combine Quiet-STAR's inner monologue with existing techniques like chain of thought, where an AI basically talks through its reasoning step by step, the performance gets an even bigger boost. In other words, teaching an AI to think quietly actually makes it better at thinking out loud, too.
This research really opens up an exciting future for AI. But, it's also important to be realistic about where we are right now. So let's look at the current limitations and the path ahead.
The researchers are really upfront about the current limitations. For one, this method requires a ton of computing power. It's also only been tested on one specific model size so far, and we still don't know how well it would work if you were training a brand new AI from the very beginning.
But these challenges also point to a pretty thrilling path forward. I mean, imagine an AI that could dynamically decide for itself when to engage in deep thought, or one that could weigh multiple internal arguments to find the absolute best answer. This research feels like a crucial step toward creating AIs with more general and, frankly, more human-like reasoning.
Which leaves us with a final, pretty provocative question. We are at the very beginning of teaching machines how to think. This work is a monumental step for sure, but it leads to a pretty profound thought. What happens when an AI's inner monologue becomes faster, deeper, and more complex than our own? This is for entertainment purposes only.